Everything in the universe is made up of matter, from the benches in Zabel Stadium to the turf and even the scoreboard. Tiny objects called atoms determine how we interact with everything around us. Within these atoms, even smaller objects determine how atoms interact with each other. Everything is tied together in increasingly small ways.
Everything we see in nature is composed of protons and neutrons and electrons. So if you think about matter composed of atoms, and atoms have two parts to them. There's the nucleus of an atom, and there's electrons orbiting around that nucleus.
This ping pong ball placed in the middle of Zabel Stadium represents the tiny nucleus of an atom. The stadium around it represents the electron cloud. Matter, which appears to be solid, is really just made up of a lot of empty space.
Electrons, as far as we know, are fundamental particles, so there's no substructure to them. The nucleus of an atom has substructure, so the nucleus consists of protons and neutrons. Protons and neutrons also have substructure, so there are those particles called quarks, which make up protons and neutrons.
The three quarks found in a proton or neutron are represented by the colors blue, green, and red. While a proton or neutron is made up of these three individual quarks, they appear as one solid object. Imagine spinning a disk with these colors. When it picks up speed, the disk looks like one white blur. The Standard Model explains the interactions inside of a nucleus between the various subatomic particles.
So we have, first of all, the quark sector, which has the 6 quarks that are interacting with each other. So we have the lepton sector, which consists of the 3 families of leptons. And then the third group of particles is the group of the force-mediating bosons, as we call them. A long time ago, when those particles were first discovered, the electrons and muons, and so this whole structure of the Standard Model wasn't there, and people weren't aware of the fact that there might be not just more than 2 quarks, but that there might be quarks at all. The assumption was that the neutrons and the protons were just the most fundamental particles there was. And there could be more particles to the Standard Model. Right now, the Standard Model provides a decent description of what we see in nature.
These tiny objects hold the keys to the big questions. Despite what is known about the Standard Model, there is still much more to discover.